Okay, we've got this other example here to do just to show you how things work depending on what they also ask for. In this case, we're being asked to find the area between the sine of x and the x-axis between 0 and 2 pi. If you were asked to find the area between that, and also if you've been asked to find just a definite integral between 0 and 2 pi, you're going to get two different answers. We'll start off with definite integral first. So we go between 2 pi and 0 for sine of x with respect to dx. This will become negative cos of x between 2 pi and 0. So we substitute those values in, so we get negative cos 2 pi and minus negative cos of 0. Need a random bracket. So put a square bracket, 0. Now if we solve for this, we know cos of 2 pi is 1, so it becomes negative 1 minus cos 0 is also 1, so we've got negative 1. These two will become a plus, so we've got negative 1 plus 1, so we end up with 0. So it's a definite integral. However, the area is different. If we were to sketch that, there's our sine of x. Now, what do we notice about these two areas? Well, one's positive and one's negative. So because of that, we're going to have some cancellation going. So we're going to have a look at that. So basically, there's a couple of ways we can do this. I like to think of it as though we're going to have a positive area here. Anything below the x-axis is a negative area. I like to think that we'll add them. We take this, I take the absolute value of the bottom area, and we add it to that. Some people, though, subtract the areas. So we take this minus that, because we're doing a minus something minus a negative, we end up with a positive answer, but we'll have a look at it. So we know that as a function, if we've got sine of x, we're going to set the 0, pi, and then 2 pi. So what we need to do here, we need to set up two integrals. So we're going to go between pi and 0 of, sine of x dx. Then we're going to say plus the absolute value of 2 pi and pi for sine x with respect to x. I'm running out of room. So what we'll do for sine of x, when this becomes negative cos x between pi and 0, then we're going to say plus the absolute value of negative cos x between 2 pi and pi. So from here, we're going to substitute pi in. So we're going to have negative cos of pi minus negative cos of 0. And then we're going to add the other part later on. So we'll just worry about the first part there. So we've got negative cos of pi, so we end up with negative 1 minus negative 1. So over here we've got, we'll end up with, just checking my results. So we've got negative 1 minus negative 1, so we end up with 2. So now we'll deal with the other part. So we've got negative cos, we're going to substitute 2 pi and pi. 2 pi minus negative cos of pi. So negative cos of 2 pi gives us negative 1 minus negative cos of pi gives us negative 1. So it become positive. So we've got negative 1 minus 1 with negative 2. Now, like I said before, we're taking the absolute value. The absolute value of that gives us 2. So with 2 plus 2, which gives us 4. So that's our area for there between 0 and 2 pi, for sine of x.